Welcome to This Explainer. Today, we're going to explore a completely fascinating mathematical mystery. And the craziest part? It's secretly hiding right in your own backyard, in the art museums you visit, and literally inside your own DNA. I promise you, once you see this hidden code, you're never going to look at the world the exact same way again.
So, let's just jump right in. Picture a simple daisy, or maybe a pine cone. Have you ever actually stopped to count the petals on that flower, or trace the way the seeds spiral outward on the pine cone? Most of us, we just see a pretty plant and move on with our day. But if you look closely, there's actually a strange, flawless mathematical perfection in how these things grow. Because it turns out, these incredibly specific petal and spiral counts, they aren't random at all. Lily pads almost always have 3 petals. Buttercups usually have 5. If you pick up a pine cone, you'll pretty much always count 8 spirals going in one direction and 13 going the other. Sunflowers packing exactly 21 and 34 spirals. And daisies reliably bloom with 34, 55, or 89 petals. Every single one of these examples follows a highly specific, very special mathematical sequence.
Section 1. The Man Behind the Math, Leonardo of Pisa.
To understand why nature so religiously uses these exact numbers, we have to travel back in time. Now, while this math was actually first described in ancient Indian texts hundreds of years earlier, it was an Italian mathematician born around 1170 who truly brought it to the West. His name was Leonardo of Pisa. Hilariously, his own townsfolk playfully called him bighellone, which basically meant absent-minded or daydreamer. Today, though, we know him as Fibonacci. And in 1202, he published his absolutely groundbreaking book, Liber Abaci. The really interesting thing is that in his own lifetime, Fibonacci wasn't actually famous for nature's spirals at all. He was famous for sparking a numerical revolution. He's the guy who imported the highly efficient Hindu-Arabic numeral system, the digits 0 through 9 that we use today, over to Western Europe. Before him, Europeans were stuck using those clunky Roman numerals that didn't even have a 0. Imagine trying to do basic merchant arithmetic with Roman numerals. It was a total nightmare. So Fibonacci's work saved everyone a massive amount of trouble.
Section 2. The Simple Math Explained.
Hidden inside that very same revolutionary math book was this bizarre, almost playful little word problem that would unexpectedly cement his legacy forever. Fibonacci posed a theoretical question about breeding rabbits. He laid out these rules. You place one pair of rabbits in a walled area. In their second month, they become productive. And every month after that, each productive pair gives birth to a brand new pair. He simply wanted to calculate exactly how many pairs of rabbits you'd have after 12 months. But tracking them month by month revealed a stunning numerical pattern. And here is the rule behind that pattern. It's so beautifully simple. Starting with 0 and 1, you just add the last 2 numbers together to get the next one. So 0 plus 1 is 1. 1 plus 1 is 2, 1 plus 2 is 3, then 2 plus 3 is 5, 3 plus 5 is 8, and it just keeps going. 13, 21, 34, 55, and so on, forever. It's an infinitely expanding sequence born from literally the most basic rule of addition.
Section 3. Unlocking the ratio, the golden ratio.
Once you grasp this sequence, you hold the key to unlocking an even deeper geometric mystery. Something fascinating happens when you start dividing these successive numbers. If you divide a number by the one right before it, say 3 divided by 2, you get 1.5. No big deal, right? But as you use larger and larger numbers from the sequence, like taking 233 and dividing it by 144, the result zeroes in on a very specific, almost magical decimal, 1.618. This number is universally celebrated as phi, or the golden ratio.
And this ratio translates directly into physical geometry. When you actually map this out, building squares using the Fibonacci numbers as their side lengths, starting tiny with a 1 by 1, then a 2 by 2, a 3 by 3, a 5 by 5, and an 8 by 8, they perfectly tile together. The outer boundary of this entire shape creates what mathematicians call a golden rectangle, and it's widely considered to be the absolute most visually pleasing rectangle to the human eye.
And here's where it all comes together. If you take a compass and draw a curved arc right through the opposite corners of those steadily growing squares, you create a seamless, perfect curve. This is the famous Fibonacci spiral. It's literally the exact same spiral we see staring back at us in the center of a sunflower or wrapping around a pine cone.
Section 4. Art and Architecture. Spirals by Design. Because we humans find this specific mathematical proportion so inherently beautiful and balanced, we've actively mirrored it in our own creations for centuries. Legendary artists have long referred to this 1.618 ratio as the divine proportion. They use it as a sort of hidden scaffolding to make their paintings feel perfectly balanced. Geometric painters like Piet Mondrian heavily relied on these Fibonacci-based rectangles. And the great surrealist Salvador Dalí, he explicitly mapped out the golden ratio to construct the perspective of his iconic masterpiece, The Sacrament of the Last Supper.
It goes way beyond the canvas, too. The legendary Swiss-French pioneer of modern architecture, Le Corbusier, relied heavily on this exact math. He actually baked the golden ratio directly into his famous modular system for building design. He firmly believed that scaling architectural proportions to this mathematical ratio created spaces that felt harmoniously perfectly aligned with the human body.
Section 5. Why Nature Loves Math. Biological Optimization.
Now, while humans consciously use this sequence to make things look beautiful, the natural universe seems utterly obsessed with it for a completely different, far more practical reason. You'll find this sequence operating on literally every conceivable scale of existence. We see it in the spiraling shells of snails in the Nautilus. It dictates the curl of crashing ocean waves and the terrifying eye of hurricane formations. If you look closely at your own hand, the links of your finger bones actually follow Fibonacci numbers. It scales all the way down to the microscopic twists of human DNA and all the way up to the massive, swirling arms of spiral galaxies.
So why on earth does nature do this? Well, the Fibonacci sequence isn't magic. It's pure biological optimization. Evolution figured out that this sequence is the absolute most mathematically efficient way to pack seeds into a tight space. By growing leaves or seeds in a Fibonacci spiral, a plant maximizes its physical space and minimizes overlap. This ensures every single leaf gets the maximum possible amount of sunlight and rain. Nature is optimizing purely for survival and efficiency, and the byproduct just happens to be this breathtakingly beautiful math.
The sequence is so incredibly ubiquitous that math enthusiasts around the world actually celebrate an official Fibonacci Day. It falls on November 23rd. Why? Because if you look at the customary US calendar shorthand, 11/23 perfectly matches the first 4 digits of the sequence, 1, 1, 2, 3.
So, as we wrap up this explainer, I really want to leave you with this thought. You now possess the key to seeing the hidden, underlying architecture of the world around you. From the produce aisle at your local grocery store to a quiet walk in the woods, the divine proportion is literally everywhere. Now that your eyes are completely open to nature's perfect hidden code, where are you going to spot the spiral next?